Hello! So today we're going to be working on lesson 15, which is putting everything together we've done and also adding some fractions in because we need to feel very comfortable with fractions at this point. So we'll start with lesson 15, example number 1, and I'm actually going to read that to you today. Sam's mother had entered a 10K race. Sam and his family want to show their support of their mother, but they need to figure out where they should go along the race course. They also need to determine how long it will take her to run the race, so that they will know when to meet her at the finish line. Previously, his mother ran a 5K race with a time of 1.5 hours. Assume that Sam's mother ran the same rate as at the previous race in order to complete the chart. Create a table that shows how far Sam's mother has run after each half hour from the start of the race and graph it on the coordinate plane to the right. So I'm going to scoot this down a bit and looking back, so for my time it wants me to graph it for each half hour from the start of the race. So at the start, 0 time, 0 distance. I feel like I'm always off screen on this. After half an hour, we'll see 1 hour, 1.5 hours we know. That was 5K. So then the next would be 2 and then 2.5. So let's find out what our unit rate is. This is X, this is Y. Y divided by X, 5 divided by 1.5. I'm actually going to use a calculator for that part. Scoot that over so you can see it, maybe. So I'll do 5 divided by 1.5 inside my calculator. Okay, now this is 3 3/10 repeating. I know that's 3 1/3. So I think it would be better to write this as a fraction. So that's the route I'm going to take. I'm going to minimize my calculator. If that's 3.5, then it would be 1 and 3.5. I wonder what half of that is, because now I need half. Divided by 2. 1 and 2/3. Okay, so it's 1/3, not 1/2, 1/3. Okay, so now I'm going to do that, let's see, times 2, clear, okay. So my little computer calculator is not working very well for this fraction, so I just pulled up the Desmos calculator that we've used before, and I used it because it'll let me do fractions. So 3.5 times 2 is 6 and 2/3. And then I'll go ahead and do 2, let's do half, and then go backwards and do 2.5 times our unit rate, which is 3 1/3. Okay, so that's 8 1/3 for this. And then I was supposed to graph each of these. So I'm going to pause this and graph these points on this graph. So I just wrote my ordered pairs here, and then I graphed them here, thinking about where would 1/2 be, right between 0 and 1. Where is 1 2/3? Almost to 2, but not quite. Now that I have my points graphed, I'm just going to use a Post-it note. You could use a piece of paper or a ruler. I'm going to connect those points. So what are some specific things that we notice? Well, hopefully we notice this is a line, and we notice that it goes through the origin, which means that it is proportional. Hopefully at this point we are noticing and looking to see if our relationships are proportional. So the connection between the table and the graph, well, they are representing the exact same information. They look a little different, but it's the exact same information. This is my unit rate. My unit rate is also here at this point 1R that we've talked about, and in this situation it's 1 3 1/3. So it's also here in the table. And then what does this particular point represent in context of the problem? So in this situation, so it would be 2 hours, 6 2/3 kilometers. In other words, Sam's mom can run 6 2/3 kilometers in 2 hours. Okay, here's our next situation. This is gourmet cooking. After taking a cooking class, you decide to try out your new cooking skills by preparing a meal for your family. Wow. You have chosen a recipe that uses gourmet mushrooms as the main ingredient. Use the graph below, complete the table of values, and answer the questions. So, I added these lines in here just like for organization because they were all jumbled up. And I think that's just the way it printed or something, but it's all jumbled. So, I'm going to figure out how to find my missing values by using the table. Look here, 1 8, 1 8. 16 is the cost. Cost 16, well that's 2. Okay, is the relationship proportional? How do you know from the graph? Yes, straight line through the origin. Line through 0, 0. This is old news. Okay, what is the unit rate or the cost per pound? So the unit rate is here. The unit rate is here. The unit rate is also, if I do y divided by x, each time I get 8. And if you don't believe me, do it on Desmos or a calculator or mentally by hand if you can. Okay, the unit rate for the cost per pound is 8. It is $8 per pound. So if we were going to write an equation to model this, we could do y equals 8x. Maybe we also want to use, let's see, what if we also wanted to use the letters they gave us? Let me straighten my X out a little, make that neater, I'm sorry. So what if I want to do cost and weight, okay? The cost equals 8 times the weight. Because sometimes that's what happens. We're asked to use the variables representing these instead of X and Y. Okay, so there's my equation. For the unit rate, I could also pick any point, okay, just like we did here, and I could do like 12 divided by 1 1/2, get 8. Because sometimes you might not be able to tell what the 1 is on your graph, and in that case you can take any y value and divide it by x to get the unit rate, which we called K, or some mathematician back in the day called it K. What ordered pair represents the unit rate? Well, spoiler alert, I already talked about that. 1 8, and that means $8 for 1 pound. Okay. What does this ordered pair mean? It means 2 pounds, that's the abbreviation for pounds, for $16. If you could spend $10 on the mushrooms, how many pounds could you buy? Well, I don't know. Sounds like a job for a highlighter to me. 10. Okay. So right here's where that would be. How many pounds can I buy? Looks like it's right. That would be right between maybe the 1 and the 1 1/2, so 1.25. But I probably want to be real precise. So let's use our equation to figure it out exactly. Now the 10 is the dollars, and that's the y. So 10 equals 8w. I'm just using my equation to solve the problem. Divide each side by 8. So the weight would equal, I think the regular little calculator will be fine for this. I don't think that worked out. Let me clear it. I'm doing 10 divided by 8. Now, I'll tell you what. That was good that it worked out that way. but most of the time you can't really tell just by marking. You would have to actually do the math. Okay, so 1.25 pounds. What would be the cost of 30 pounds of mushrooms? So this time, we're using our same equation, because that is the equation that represents the situation, trying to find the cost of about 30 pounds of mushrooms. I think that would be a lot. This must be for a big family. 30 times 8 is 240. Oh yeah, $240 just for the main ingredient? This might be the family reunion. Sometimes these problems make sense in the real world, and sometimes they don't. All right, so that's your lesson, per se, for today. Had some pretty good examples. I liked everything except for this last part. That didn't really make sense, but we could still solve it even if it didn't make a lot of sense. So now we've got a problem set to do. I'll do that in a different video. Have a great day.